Hello, welcome to next session. In this session, we'll solve some questions of theory of machine. The topic is dynamic force analysis. Question number 1 to 6 carries a common statement. The statement is a horizontal gas engine running at 210 rpm has a bore of 220 mm and a stroke of 440 mm. The connecting rod is 924 mm long and the reciprocating parts weigh 20 kg. When the crank has turned through an angle 30 degree from inner dead center, the gas pressure on the cover and crank side are 500 kilonewton per meter square and 660 kilonewton per meter square respectively. Diameter of the piston rod is 40 mm. Determine 1. Piston effort, 2. Force along connecting rod, 3. Crank effort, 4. Thrust on cylinder valve, 5. Thrust on bearing, 6. Turning moment. So here this is for the arrangement of piston cylinder arrangement or slider crank chain mechanism or horizontal gas engine. Okay, so this is your slider and this is your crank, this is your connecting rod, and connecting rod is and crank is making an angle theta and connecting rod is making an angle beta at a particular resistance. Okay, so at in the given condition theta is given as 30 degree and uh, length of stroke is given as length of stroke means the travel of the piston is 0.44, so radius of the crank will be 0.44 by 2, that is 0.22, and mass of the piston is given as 20 kg, n is given as 210 rpm and L is given as 0.924 meter. So L is given as 0.2924 meter and N is given as L by R. 0.924 by R is 4.2. Okay. So and from N we can find out omega. So omega will be 2 pi into 210 by 60, that is 22 radian per meter. Okay. This angle is beta, this angle is theta. So R by sine beta will be equal to L by sine theta. So it means sine beta is equal to sine theta by n, or sine theta means here theta is 30 degrees. So n is your 4.2. So sine beta will be your 0.119 or beta will be your 6.837 degrees. Okay. Now F is your suppose F is your gas pressure force due to gas, and as there is pressure on both sides of the piston, so pressure force of the gas is your 510 over 3 into pi by 4 into 0.22 scale. Okay, and on one side and on other side we will not take the area of the piston rod, so we'll take the only the area of the piston and minus the piston rod. Okay, so area of the piston is pi by 4 0.22 square, and if we subtract the area of piston rod, then it will be, will subtract here 0.004 square, because diameter of the piston rod is given as 40 mm. Okay, and the pressure on the other side is given as 60 into 10 over 3. So pressure 60 and here on the one side pressure is 500 and piston rod diameter is 40 mm and the piston diameter is given as 440. Bore diameter is given as 220. Okay. So from this we get the force due to pressure will be 19007 minus 2206, that is 16801 Newton. So that is Fp, and the inertia force is Me. M is mass of the piston and A is your acceleration of the piston. So that is acceleration of the piston is R omega square cos theta plus cos theta by n, and R is 0.22 and omega is your 22 and omega is your 22 and theta is 30. Okay, and n is your 420. So this is your inertia force. Inertia force is Fb. So it comes out at 2098. So now the piston effort will be the net pressure force acting on the piston minus that inertia force. Okay, so inertia force is 2098. Okay, so the piston effort will be Fp minus Fb, that is 16801 minus 2098. So that is 14703 Newton. So the piston effort will be 14703 Newton. And so this is your piston effort, and Fc is your force along connecting rod. Okay, so if we know Fc, if we know F, so we can find out Fc because angle between F and Fc is your beta. So the force along connecting rod is your Fc by cos beta. So that is 14703 divided by cos beta we have found out, that is 6.837. So that is 14808. Okay, and the crank effort is your Ft, and Ft is perpendicular to the crank. Okay, so if this angle is beta, this angle is theta, then this angle will be 180 minus beta minus theta. Okay, as this is your straight line. Okay, so this angle will be your beta minus theta. As this is perpendicular to crank, so this angle will be 90 minus beta minus theta. Now 90 minus beta minus theta, or 90 plus beta, 90 bracket plus beta plus theta. Okay, so so if we know that angle, now we have now this angle is known, and this angle is 90 minus beta minus theta, and the crank effort will be at Fc into cos of this angle. Cos of this angle means cos 90 minus beta minus theta means uh, sine of beta plus theta. So that is sine beta plus theta. Okay, so from this we can find out crank effort, because Fc is known, Fc we have just found out, that is 14808, and this is your 30, and this is your 6.837. So that is 8877 Newton. Okay, so now this is your 8877 Newton. Fc is your 88 sorry Ft is your 8877 Newton. And now other thing is thrust on cylinder wall. Thrust on cylinder wall, cylinder is here. Okay, and this is your thrust on cylinder wall. So if we know Fc, then sine component of Fc is your Fn. So Fc sine beta is your thrust on cylinder wall. So that is 14808 into sine 6.837. Okay, so that will be 1762.82 Newton. So next is your thrust on bearing, and bearing is between connecting rod and crank. So if this is your crank effort, so then this will be a thrust on bearing, Fr. So Fr will be, if Ft is your sine component, then Fr will be your cos component. So Fc cos theta plus beta is your Fr. So Fr will be 14808 cos 30 plus 6.837. So that will be 11852 Newton. Okay, now so that is thrust and bearing is known. Okay, so now the turning moment is Ft into R. Ft is your Ft is this quantity, and R is radius. Okay, so Ft is 8877 and R is 0.22. So that is Ft we have found out, that is crank effort. Okay, and if we multiply it by R, radius of crank, then it will be turning moment. So that will be 1952.94 Newton meter. So answer is